So I'll just go ahead and kick it off. For those of you who have joined us today, thank you so much for lending us your time at lunch on this lovely Monday. We do see a few familiar faces, and I have the pleasure of introducing Sanjeev Das, who actually I also had the pleasure of seeing and introducing a week or so ago at our Program for Financial Studies News and Finance Conference, where he presented more on the research and academic side of what he'll be walking through today. So Sanjeev is currently an Amazon Scholar at Amazon Web Services, but he's also the William and Janice Terry Professor of Finance and Data Science at Santa Clara University's Levy School of Business. He has had faculty appointments at Harvard Business School and UC Berkeley. He has a background in finance and computer science and is an expert in derivatives. He has published a book, Derivatives Principles and Practice, in 2010, with a second edition updated in 2016. And he used to work in the derivatives business in the Asia-Pac region at Citi. So Sanjeev comes today with a wealth of knowledge in certain product areas, but his focus of today's presentation, which he will go through in much more detail than I can possibly introduce, is to introduce everyone here today to the AWS SageMaker Jumpstart product, which really is about democratizing AI and natural language processing technologies for easier, faster, cleaner input modeling for academic research. So if those of you who've joined us are faculty, PhD students, master's students, please feel free to let us know from what lens you are approaching today's presentation so that we can make sure to approach you and the questions that you have in the right way. And without further ado, I am delighted to hand over the presentation to Sanjeev, and I will just let you kick it off. And Sanjeev, just make sure to go over the sequencing as well of this and then our second follow-up workshop, just so everybody can anticipate it.
Absolutely.
Great, thank you.
Thanks, Melina. Thanks so much for having me, and thank you all for being here. I see Harry is joined, so hi, Harry. How are you? And so this has sort of been a journey. When I joined Amazon as a scholar, they gave me a lot of freedom to do, things that were interesting. And so I've always wanted to build tools that I wanted, and I figured a lot of other people might want. And so, spent a year and a half building a whole bunch of things that I'll present to you today. And hopefully are easy to use that people can pick up and run with it. All right. So one of the things I've always wanted to do was sort of do training of models on multiple modalities. And it's kind of hard to do that, without having access to a large amount of computation. And so this was a good opportunity to try that out. I also feel that it's a good place where you can extend the range of research you can do, because we've most of the time done econometrics on tabular data. And that's what we really trained well to do. And I think now a lot of finance and economics academics are sort of rotating into using machine learning as well. And it's become sort of, wild craze at this point. And hopefully this will help you in the journey to do it, faster and quicker. At the end of the day, the question is the most important thing. The analysis is the most important thing, not necessarily the tools, but sometimes you can spend, 80% of your time just tooling and getting data ready to do the analysis. And so this might help as well. Okay. Any opinions I express are my own, all that usual stuff. So just want to say that. So I want to go over a whole bunch of things today. But before I start, I just want to mention that today is really just a presentation, a little bit of demo. But what I found most useful is that, about 10-15% of the people who watch these talks at other universities have come back and said, we want to use it, but we don't know how to use these tools because we don't have any cloud experience and so on. So what I can do as a follow-up is actually have anywhere from 2 to 3 hour workshop where I actually give you free accounts and walk you through it. When I did this, at the early iterations of this, I used to actually do it myself and people would follow me. They'd log into their own accounts, which I spun up, and they would follow me and do it themselves. So they learn how to do it. But then I found it's even more effective if I pick on somebody like Harry and say, Harry, you're the one who's going to do it. I'm going to tell you what to do, because that goes at the right pace for everybody. So that's sort of something that we're not doing today, but just let me know when you want to arrange that, and I can, schedule that with everyone, and then we can go through that hands-on workshop as well. Okay, so I'll try and motivate multimodal machine learning. Talk about, how it extends econometrics, I'll do credit scoring as an example because that's a nice popular one and easy for people to sort of follow. And then a little bit of the underlying plumbing. I'll go into that as well. Like what's the code that actually runs all this underneath. So you know how it's, what's there and compare it to any other things that you might be using. I'll also talk a little bit about the Altman Z-score model, which has now been, is extended with text in it. So it's kind of an interesting application. We published a paper on that. I'll of course talk to you a lot about SageMaker Jumpstart, which is the internal AWS tool for all this. And then a little bit about curating SEC data sets in one function call. So you don't have to spend 6 months writing code to get your own SEC data sets. And then we also built pre-trained language models for finance, transformer models that you can use to do NLP with, and so on. Okay, so and I'll end with a little bit about what AWS does to support this for teaching and research. So you can actually use this in class if you like as well. Just as way of introduction, Jumpstart is not just about what I did. It's a much larger family of solutions. There are about 350 different notebook solutions that you can use. So I'm actually in the process of trying to figure out how to wrap an entire course around it at the university. So if you want to teach sort of machine learning and you want to cover a whole bunch of topics, you don't even have to build anything. You just walk through Jumpstart and pick off the ones you want and teach them. Okay, so I'm just going to make a few assumptions about who's here. I'm assuming that people have a working knowledge of Python for research, and you've been using Jupyter notebooks and so on, because everything that I'll show you is in Jupyter notebooks. But if you don't, that's fine too. I mean, most of the code here is what we call low code. You don't have to really do anything but modify it. So you don't have to sort of write anything from scratch. I'm assuming also people have a reasonable working knowledge of machine learning, and if not, a good knowledge of econometrics, because a lot of the paradigms are not that different. And then I guess many folks are not actually doing a lot of multimodal machine learning. So, that's sort of an interesting extension here. Okay. I presented some of this at the conference, this whole thing about multimodal data becoming new. Unimodal data has been, I think, really well solved in computer science. We've got incredibly good machine learning paradigms for tabular data, for text, images, voice, video, and so on. Okay, so and for natural reasons, I think econometrics has been effectively run mostly on tabular data, and so it's or you have to do things to get econometrics to run on other modalities, and so it's generally harder. So machine learning has actually come in at the right time, just when a lot of additional data is available. Now we can kind of do things with it with machine learning that may not have been that easy to do with econometrics. Here's a trader, for example, looking at a whole bunch of different modalities. You've got images of charts, you've got pictures on the screen out here on the left, for example. You've got the stock tables and things out here. So those are like standard data sets, tabular data sets. And then you might even have news and text that's scrolling through. That's language. Okay, so you can have a lot of modalities here, and all of them can get used effectively. So I'm just trying to make this thing scroll. PowerPoint is stuck. Not sure what happened to that screen. Sorry. Okay, try it again. One second, I'm just going to close this and see. Something went wrong with my screen for some reason. I'm not sure. Okay, let's reload that. All right, it will come up. Okay. My PowerPoint is stuck. It isn't opening. Oh, there it is, finally. Here we go. Down here. Yeah, so So I just want to mention that, one of the other things that's interesting over here is the fact that multimodality might actually lead to using less rows in a data set than you need with a single modality. To train machine learning model, you need a lot of data. And this argument been made that children seem to learn from very few examples. And the rebuttal to that has also been that, children are multimodal learners. And so they actually get context from many different modalities, and so don't need to see that many examples to actually learn from, unlike machines that currently have been doing unimodal learning. Okay, so Jumpstart is the sort of environment in which all this has been built. Let me just, you can obviously just Google it and get the landing page of Jumpstart and see what all is there. But SageMaker is the entire sort of, the ecosystem in which this works. And I'm just going to show you very quickly how to get into it. So this is my sort of console when I've logged into Amazon Web Services. You can click on the console and then go into this entire landing page. And in fact, if you click on services, you get to see all the different services that Amazon has, including like blockchain stuff and Internet of Things, machine learning, and so on. So there's hundreds of services. Of those services, I use a small number of these. And SageMaker is the one you actually use. So if you click on, so you can log in, if you get an account, you log in as well. You click on Amazon SageMaker, it opens up SageMaker. And SageMaker is the entire machine learning framework inside Amazon. So all of the internal stuff is done on this. Every machine learning is run over here. And it actually has R, it has Jupyter, and it has Canvas, which is completely AutoML and no code at all. Okay, so if I click on SageMaker Studio, I go into my domain here, and then I can click on my name and get it. So I've already done that, launch my app here, and then I'll be inside my environment. Okay, so it's basically Jupyter in the cloud, but with a whole bunch of extra bells and whistles that you don't usually get if you install Jupyter locally. So I've already done that. So I'm going to close this window. I have this window open here. And this is Jumpstart. So the little icon here is Jumpstart. So if you get into Jumpstart and click Browse Jumpstart, you get this particular page here. So Jumpstart contains solutions. A solution, by definition, is an end-to-end example of something you can do with machine learning. So I'm going to show you this one, for example, today, the corporate credit rating prediction one. It literally ingests the data, does all the machine learning, deploys it to an endpoint, and then you can call the endpoint for inference. Okay, so for example, if you actually want to take the model to production and deploy an endpoint, you could do that and then send new observations to the endpoint to get predictions. So there's a whole bunch of these solutions out here. Some of them I'll show you today. So NLP dashboard. So a lot of people try to download the SEC filings for the last week and then curate them and so on and so forth. So this solution does all that for you automatically. You can do churn prediction, for example, if you're looking at insurance repricing. And then there's a whole bunch of transformer models that were pre-trained on SEC text plus all of Wikipedia and so on. All right, so there's all these. So those are called solutions. Then there are text models. So if you're trying to teach, let's say, BERT or Robert or anything else, and you want to get embeddings for that, there's a whole bunch of those. But there are actually 110 different notebooks we built for all these different use cases. So if you want to do sentence pair disambiguation, you want to just do text classification using different types of models. All these are open source, but they've been packaged so that you can use them. You can do summarization, for example, question answering notebooks, and so on and so forth. So question answering is an interesting thing. If you have like an analyst report and you just want to query it for some things, you can actually use machine learning to ask questions and get things back. Okay, so there's a vast number of, there are about 110 of these we built, and we are building more so that you can use them. There's also vision models that you may or may not be interested in, because in finance we don't do that much of it yet, but there's a whole bunch of these different things for images. There's also tabular models, just standard regression models, to a whole bunch of XGBoost type things that run at scale. So these are really designed not for maybe academic data sets, but they're also designed for things which have billions of rows of data, so you can run this stuff at scale if need be. There's also algorithms. So, similar things that are specific algorithms that are widely used. And so the popular ones are trained up. And then there's notebooks, blogs. So for example, within notebooks, there's further things like, how do you construct a data set that's a mixture of tabular and text data? this is a simple use case where we try to predict who would return money in the Paycheck Protection Program. So it's literally a paper, but the whole thing is written as an application. This is just how do you do multi-category classification on SEC data and so on. Okay, so there's just a whole bunch of these different things in here, and I'll show you a few of them today just to get people on the same page. Okay, so that's SageMaker Jumpstart. So just remember, you have your cloud account, you get into, oh, my screen is not refreshing properly. Sorry. Yeah, there we are. So yeah, so SageMaker is the machine learning framework, and within that, Jumpstart is a particular set of 350 to 400 different solutions. Okay, so it's really been designed for people to get started with machine learning. So save your time, don't need any knowledge of cloud infrastructure. So I just did 3 or 4 clicks and I was into that environment that allows me to build it. And then, all the different steps in building, training, and deploying models are taken care of. So there's a whole bunch of model cards in there. These are some of the finance cards that are actually provided, but there's other applications as well. Now, when you look at a solution like corporate prediction, it's just one example. You could literally swap out the data with some other data and do something completely different with it, but you wouldn't have to change much of the code there other than the data set that you pulled in. Okay, so let's take an example. If we want to do credit predictions, and we did it the standard way, usually it's done in 3 steps. People will sort of train a tabular model, and the rating agencies have been doing this for about 3 decades already. They've been using neural nets and getting a prediction of a probability of default or a rating. That's on tabular data. Then the typical way rating is done is, you have the initial, information, which is mostly tabular. You have an initial rating that's been predicted by a model, and then there's a small rating committee that gets into a room, reads the SEC filings, summaries of it, the analyst reports, and so on. And then they sort of do the text part of it manually and then notch the rating or adjust the rating. And the text also helps in spinning the story as to why they gave a AA rating or a AAA rating to a particular company. What you can do, of course, is replace all that with a machine. Parts 2 and 3, which are not machine run right now, can be replaced. You get actually more accuracy, better precision, and recall, because now you've got text and tabular data in the model. You don't need a human in the loop. And in fact, the latest advances in natural language generation are being used to actually write, interpretations for the rating that's actually been produced. So Morningstar recently, about almost a year ago, a little close to a year back, actually had started doing this. They rate 5,000 companies, a long tail of companies that very few analysts follow, and a small core of companies like the 80-20 rule that really get followed. So, rather than spend time on a whole bunch of small companies, you can have the machine actually write those out. So they published this there was a big news article in FT that actually talked about it, but NLG has come to the point of maturity where you can actually write the explanations as well. Okay. So, what normally goes into credit models depends on who is doing the rating, but these are sort of the standard ones. I just put Moody's here as an example. These are just the standard variables that often go into a credit classification model. And I'm just going to show you an example on a data set, which has about 25 different financial indicators. That's the tabular data. To that data set, the data set has a bunch of ratings. This sort of reflects the standard distribution of ratings in the US economy. Few AAAs, more AAs, even more single A's, and so on. To that, we added industry code. Obviously, we know industry is an important variable in determining a rating of a firm, but we also added ticker. And the ticker was added for a specific reason, because we wanted to actually anchor ratings. Ratings don't migrate from AAA to CCC all of a sudden. They tend to sort of migrate slowly. And so the ticker symbol actually, which normally doesn't show up in rating data sets, because if you did like dummies on tickers, you just get hundreds of tickers, right? And that just adds columns, crazy columns. But machine learning actually uses the ticker to be an anchor. And so you get actually slightly better rating predictions if you use the ticker symbol as an anchor, because it sort of anchors to the previous observations of that particular firm. We also added in the management discussion analysis section from the SEC filings, and you could add in different text. This was just one particular example. So we have a tool that actually downloads these SEC filings and curates a data set in one function call, and we can join it with a data set of financials. So we call that tab text for tabular plus text. So the data frame is called tab text. We also have an API that will actually generate 11 scores for the text. So this is very much like what people do in financial academia. You have Lockyer McDonald word lists. You know how many, you try and count how many words there are related to these concepts like positivity, negativity, litigiousness, and so on. The Lockyer McDonald word lists, we don't use them, but they are included. Same one included here. We added things like fraud, safety, added sentiment scoring in there, readability. So there's just one API call that will actually just add columns with all these numbers, and I'll show you that. We call that enhanced tab text. And so once you have this entire data frame, it's multimodal. There are categorical columns, there's numerical columns, and there's text columns. And what you want to do now is throw this into a black box that runs everything, bunch of regressions, all kinds of machine learning models, ensembles them together, and finds the best model for you. And best in the sense that on some accuracy notion, either F1 score, accuracy, whatever you want to optimize, and does that for you on the holdout data set, right? So that you actually get metrics on the holdout data set. So the whole thing is done in, actually, to be honest, 3 lines of code, because all that plumbing has been hidden under the hood. Okay, so this is really a sketch of what's running under the hood. We use AutoGluon. It's an AWS product. And what it does is it'll actually take the tabular data as is. It'll do a bunch of encodings of the categorical columns as well. In fact, there's an option in here to sort of fill in missing data and do checks on the data, everything automatically. And then it'll also take the text data that you have and build representations of it. It could build BERT type representations, transformer representations, or even just TF-IDF representations, and so on. And it'll run a family of models. I've just listed a few of them over here. But what it's going to try and do is also stack ensemble everything. And so if you look at the thing on the right, I'll talk a little bit more about it. Stack ensembling is a way of 2 things you want to do. You want to take the representations of the text and the representation of the tabular data and smart concatenate them and combine them in smart ways. And then you also want to combine all the models in smart ways by weighting them in the right fashion. And all that determinants of how you weight models has weights themselves, and those weights are determined by a neural network as well. And you train the entire stack at one go on the training data set. Okay, so there's a fair amount of stuff going on, including the bagging, which is sort of cross-validation. And everything is done at one shot and trained together. And it's done pretty fast at scale. So the idea really is that you will take input, the input is text and tabular. You might, for example, and this is just one of the things it'll do, it might build models on the tabular data set here and get predicted outputs. It'll take the text, pass it through a transformer and get a representation. Then it'll concatenate that representation with the outputs of these models and also concatenate it to the original input. So you get a massive long vector or a tensor. That tensor then gets passed through multiple models again, like k-nearest neighbors, random forests, and so on and so forth. The outputs of all these models are reweighted. And this entire blue bar here is actually a few layers in a neural network. So neural network is deciding how to weight these models. And then this is repeated. Okay, so this is just one sort of thing, and that this gets repeated many times in different stacks. Okay, so this entire stack ensembling, the whole thing is trained at one shot. And this was built, and it actually was run on all the Kaggle competitions, and it basically beats all the other models in Kaggle competitions about 99% of the time. So there's a paper on that if you want to read, is pretty interesting. So this was built into Jumpstart, and there's a whole bunch of different ways you can do that, because you can fuse the representations from text early in the stack, in the neural network stack, or you can fuse it later in the stack. So you can do transformations separately on the text and tabular data, and then fuse it later in the stack, or you can do the fusing early and then allow that fused representation to be adjusted. And then obviously the algorithm searches underneath it to figure out what's the best way to go. So if you're interested, you can read up on AutoGluon. It's here. There's a GitHub repo for it. And you might be interested in basically looking at And tabular here really means anything in a table, including text and images. Okay, so you can, and then you can run this even on image data as well. So the papers are published, the GitHub repo is available, and using this is just easy, but it's much easier to use it inside Jumpstart. So we packaged up everything inside Jumpstart as well. Okay, so that's,
can I ask you a
yeah,
question?
go ahead, Harry. Sure. Yeah.
So your training, right? I mean, in the context of like the, you know, Z scores, you're forecasting defaults, but like, is there like you need this stuff to be labeled somehow, right? So like, what kind of labels like are you expecting to have in order to do all of this training?
Right. So you have to have a data set with labels, and in this case, the labels are just the ratings of all these companies. So we are
these are ratings. Sorry.
These are ratings, correct. You could have had PDs from somewhere, but then the PDs are manufactured from. So here, what we're doing is pretty much learning. Sort of the machine is learning what the rating agency is doing, and then using it to sort of predict forward.
So Sanjeev, that's different than if you went back 20 or 30 years with default data, right, and you were calibrating the ratings based on what variables were best at predicting default. You're not doing that, which is what, let's say, an internal bank model would doing. You're training on, you're assuming that whatever source of ratings you're using is reasonable. So you're learning how to match those ratings.
Correct. You could just swap out the rating column with, you know, defaulted, not defaulted, and you would be fitting a model to, you know, the original default data itself. So yeah, absolutely. Which is what Altman did, right? Way back in 1968. He had literally had a data set of 66 companies, and he had 33 of them defaulted after 1 year and 33 did not default. He had he created a balanced sample, and then he ran LDA, linear discriminant analysis, which, correct me if I'm wrong, but I think that is the first ever example of a machine learning model in finance. We never thought of it that way, but LDA is machine learning, right? And Ed did that like in 1968.
With a wheelbarrow, the way he tells the story. He had the punch cards, and you have to take them from one end of the campus to the other.
Yeah, so it's fascinating, that when you think back, and I've racked my brains to think of an earlier example of machine learning in finance, and I haven't found one yet. But if you do find one, just let me know, because sometimes the history of these things. Yakov Amihud used to always say that there should be a journal of forgotten results, because we always keep republishing the same idea sometimes again and again, and so, yeah, but Evan, your point is well taken. It is, yes, you have to come with your labels. Now, one of the things I will show you today is a labeling exercise that Transformers helped one of my colleagues with. So one of the things you can do is actually try and find, few shot learning, which is labeling, so there's this thing called ground truth. Actually, A2I is probably the better one I should show you. If you're interested, Amazon Turk, right? We academics use it for, to get the stuff done. So the AI version of that is this. Okay, and it's basically a service where, people will label, and the AI keeps learning as the people are labeling, and then it sort of also works with the human. So it tells the human, this is a suggested label, do you agree, kind of stuff. And so you can actually spin up and prototype up a labeling machine pretty quickly. So if you have 100,000 documents to label, and you have a human work over 1,000 with the machine, and then let the machine label the remaining 99,000, that's what this is pretty much designed for. And it's a pretty cool approach to getting labels as well.
Sanjeev, may I ask another question? There were, as you know, there were two other ways of estimating default probability, one using the Merton model and using equity prices, and the other is using credit spreads. We know credit spreads overestimate default probability, but they may be useful in ranking relative ratings, even if they're absolutely overstating probability of default. Have you thought of, because you could argue that, for example, to the degree markets are efficient and equity traders are already digesting a lot of textual information, that they're incorporating that in prices or changes in the price of the equity. So have you thought at some point in seeing to what degree you could even anticipate changes in equity prices or credit spreads?
Right. I think that's a super fascinating question, because how much of this multimodality is already in the spreads or in the equity prices, yeah, that's an experiment. I haven't done anything like that. I think it's a paper to be written for sure, but what I can do, I guess, is I did have a paper way back that has nothing to do with this work, but we wanted to see how much more did accounting information add to Merton, Merton sort of information. So, so you have that, you have credit spread information, you have the Merton sort of, business to default.
I don't know if you know that there's a fellow I used to work with at Citi's, Jorge Soberhart, many years ago, built an integrated model using a Merton model and financial statement data. He called it a hybrid model. He's published it.
Correct. Yeah, I know the paper. In fact, we cite that, and there's a paper I have in JBF that actually shows that putting the two types of data together actually helps a lot. And it might be saying what I'm saying over here, which is that, hey, I'm taking financial data and adding text from SEC filings and getting a small improvement. Maybe if I added, if we put it all together, text plus Merton plus, the paper we wrote was actually explaining credit spreads with Merton models and financials rather than default, whereas, the JARO sort of framework is, Kamakura JARO framework is using the credit spread stuff to pull out the same information that the Merton models do. And they've always been that, right? Do the structural models do better? The reduced form models do better? And we've had that debate running, and I don't think it ever got resolved, right? So it's, so this is more a way of sort of trying to get the other modality into the ratings process, that is automate sort of the human in the loop, in some way, and not directly answering your question, I guess, is what's happening here.
Thanks.
Okay, so there's several experiments you can do to predict the exact rating or predict just above investment grade, below investment grade. There's a whole bunch of credit rating firms that only do the binary classification because they're interested in, is the company's currently investment grade? If it's now being predicted by the model to go below investment grade, should they put on a trade or not put on a trade? That sort of stuff. So anyway, so I'll just show you the quick results. The paper was published last year in a computer science conference. And, these financial ratios do really well. Oh, sorry. You get pretty high accuracy with the ensemble. This tool just runs all the models and gives you back all the answers. But the ensemble does pretty well already. And that's the reason these models are stuck around. I mean, they aren't bad at all. If you add those NLP scores, like just take the text and score it and add it to the tabular data, you don't get too much of an improvement. But you do get about a 4% improvement if you add the full text of the MD&A to the sample. So the error is about 16% right now. You get about 25% reduction in that error. The nice thing is that the models actually do fit really well. So even when they're wrong, the prediction is off just by one rating category rather than multiple rating categories. And this is without the further hyperparameter optimization, doing bagging and so on. And you can see if you add in the tickers, you then go up by about 2% because of that anchoring improvement, which is something I don't think has been sort of really widely noticed. And then if you do bagging on top of that, you get a little bit of an improvement as well. Okay, so that's really where we are, with this. And it's sort of an interesting evolution. Now, if we wanted to embed the whole thing into a model. So I'm going to actually jump to jumpstart and show you how we do it. So you can actually see the whole thing work. So what you would do is you would go into jumpstart and you would pick up the card. So you click on the card over here. And the first thing is that you can just click on launch. So there's a little bit of a description of the whole thing here with the data sets and so on and so forth, the architecture underlying it, which you can read. And some general information on it. So you could literally teach a class out of this, which is what I do. I go into this, I teach credit scoring, I talk about a class, I talk about the Altman models and so on. So it's kind of nice for academics to use. And then you would click on this launch button here. And what this does is it takes all the infrastructure for this particular solution, spins up a separate machine for it, and that machine actually runs in the background and takes about 2-3 minutes to spin up because you're booting up resources. Okay, so I won't run the boot up here. I've already did that beforehand. So I have the solution. Once it's ready, it'll actually show up here on the left. All you have to do then is click on it, and you'll see the solution here. Now, the solution has two parts. One is a notebook that shows you how to train your models using this solution on multimodal data. And the second part is actually there's a notebook that you can use. I'm going to change the color of this. It actually renders better if I use. Yeah. So here, there's a notebook also down here, the demo model that shows you once you've deployed this model, how do you actually run it, as a production model. But obviously that's not interesting to academics. That's more interesting to like startups use this for that sort of thing. Okay, so then you open the notebook. And the notebook has a whole bunch of stuff written into it, explaining, we had to create a synthetic data set because we're not allowed to redistribute real data. So we have a synthetic data set for this, for the example, though the paper I showed you is on real data. Okay, and so this is just the Altman Z-score model, and we're going to add text to the Altman Z-score model through the MDNA section. At the top of this, so many of you use Jupyter, I suspect, but you can see here you can choose different kernels. And so if I'm using the data science kernel right now, but if I was going to be running TensorFlow, for example, I might want to use the TensorFlow optimized image. Okay, so the installation on the machine will be optimized and pre-installed with TensorFlow. If I was using PyTorch, I could use a PyTorch one that is CPU optimized or GPU optimized and so on. So the nice thing about this is you can change the kind of machine installation on the fly and pick whatever you want. Okay, so I'm just going to leave that as it is. And then you can change the machine you want. Right now it's running on a very cheap machine, which costs about 4 cents an hour. And it's only got 2 cores on the CPU and only 4 gigs of RAM. And the reason I don't care is because I'm just running this notebook on a low performance machine, because I'm going to actually kick off these big jobs like training to another machine as well. The solution is designed that way. But if I wanted like a machine with a GPU, I would run this machine here with 16 gigs of RAM. And then there's a whole bunch of other machines I can pick from. So in desperation, sometimes I'll use a P3 24X large, which has 96 cores on the CPU, 8 GPUs, and 768 gigs of RAM. And so you can literally run some monster thing that you have without even batting an eyelid. So there's stuff that I would run on my laptop that would take 15 hours. And then I just call up this machine and it takes 15 minutes. So it's that kind of scaling that you get. And then obviously you can rewrite your code to distribute. So SageMaker has all these tools as part of its SDK for distributing rows of the data set to different machines and so on and so forth. I'll show you some of that as well. So it generally makes life a lot easier, to do things at scale. And that's why it's kind of packaged up in this way. So all you have to do is literally read the introduction, what's going on here. And then you can start running this, to have resources. So I can just set up my resources. You don't have to change anything. This is just creating resources that are needed to run the solution. Here's the data set. This is the example data set. So notice it's downloading the data set here, and it's 186 megs of data is downloaded. You can read in the data set now. So the data set is sitting on something called S3, which is simple, Amazon's simple storage. That's just like your drive on Amazon, where you can store your files, and then you copy it into this jumpstart area. So I just copied that over here, and I've opened it up by reading it into pandas, and you can see the data set. I'm going to convert it into Altman's ratios here, and then I'm going to just save my data set so that if I want it again, So all I'm going to do is train on the 5 Altman ratios, but then add in the industry code. This is the 10 category, the 2-digit SIC code categories, the management discussion sections for all those companies, and the rating. Okay, the rating distribution is over here, so you can look at that. And you can see that about 3% of the sample is AAA, 16% is AA, and so on and so forth. And then the rest of it is training. So I've actually run this before, so I'm just going to pull it up and show it to you. Because the training takes some time, and so rather than burn time here, I'll just show it to you. So we have the data set. and it has those columns, but I'm also going to add the NLP scores. And so what are NLP scores? NLP scores are run using this API. So if you look at the API on the screen, I'll just make it a little bigger. You don't have to change anything here. This is one function call that'll, you point to the text column. So I'm going to point to the MDNA column in my data set. I'm going to say my data set is this corporate credit rating data input sample. I've already created that data set in this notebook. I'm going to point to the MDNA column, and I'm going to tell it to add the NLP scores. Okay. Now the important thing here is, notice I'm just using a C518X large machine. The C5 machines are compute optimized, and that's what we need over here, but you can change it to any machine you like. And the number one here is actually saying just run it on one machine of this type. But you could say run it on 10 machines of this type, and it would take every row in the data set and distribute it to 10 different machines and pull it all back together automatically. Okay, so this API call is fully provided out here. You can see what it does is it doesn't run here locally in the notebook. It kicks off the job to a separate container, and all this stuff is the logging in the container. Okay, so the idea is to spin it off, even if you want to go for coffee and this notebook dies, that thing is going to be running in a separate container. And when it's done, it'll write the entire new data set back to your S3 bucket. So it's written back to the S3 bucket. And now you can see we've got all these extra columns with positive, negative, readability scores, polarity, sentiment, and so on and so forth. So now I have a data set of a text column, a categorical column, a label column with the ratings, Altman's 5 ratios, plus the credit scoring, all the text. Now you might think this is redundant. You've got the NLP scores here, plus you've got the text from which those scores were generated. But it turns out text tends to be noisy, and actually distilling it to these separate features does offer some improvements when you're doing machine learning. And so it's always generally a good idea to add the NLP scores as well. So now the data set is completely curated. You didn't have to make any changes other than change the one line that reads in our data set and swap it out with your data set. Over here, these lines of code, you don't have to actually do anything. You just run them as they are. Here, we're just using scikit-learn to do a train test split, so 80% for testing, holdout sample. And here, I'm just saving the train test data sets. I want to train. So I'm going to take that entire data frame. All I do is change one line at the top. And here I put in whatever the rating column is, the name of the column. That's my label. The rest of it is pre-packaged. You can change the machine if you like. You can change the name of the job, whatever you want to do here, but ideally don't change anything. And then you just kick this off. This will then run that entire giant autoglue-on model that does all the stack ensembling and machine learning for you. All that will run separately in another container. There's a lot of code behind this. And installing this on your local machine, none of that's going to work well. So we just package everything in a container so that the environment is completely taken care of. And I never really appreciated how much containers matter till I started doing this work and realized that literally, you cannot distribute software like this to people and have them install it. It just never works. So you have to literally containerize everything. So that's what we do. This thing runs. All the training is running down here. And when it's done, it writes out a whole bunch of results for you. So for example, it'll print out the leaderboard of all the models. So this is a 7-way classification problem that we were doing. And the weighted stack ensemble with L2 regularization is the model that performs best, but it's run all the other models as well. It also does feature importance. So Altman's ratio C is an important feature. The text in the MDNA is the next most important feature, and so on. So you can see the text and Altman's ratios do matter in this training as well. And then you can kind of print out the confusion matrix and a few other things. So that's over here. I'm not going to do step 7, but this is really deploying this to an endpoint. This is really, if you decided you want to make a business out of this and run it as a service, then this would actually deploy this to an endpoint. This block of this API here would send it to an endpoint, and then would sit on a live hot endpoint. And then you have another API that you can call from any notebook, as long as you have the right credentials to access the endpoint, you can call it. So over here, I just took a sample from the test data set of 5 companies. I threw them at the endpoint using this API, and it gave me back the 5 predictions over here. And then when you're done, you just want to delete your model and delete your endpoint so that you're not, paying for the service if you're not using it. You close everything down and you're done. Okay, so this entire notebook literally will do multimodal for you. You can come to this point with your data set, just swap out your data with any other data. These documents here are very large. There are about, the average size on MDNA section, actually computed this, is about 5,000 words across about 12,000 MDNAs. And so these are big chunks of text, they're not small. Normally we'd have to do a whole bunch of text processing ourselves. You literally don't have to do anything. The underlying subsystem takes care of the entire calculations for you. Okay, and this is a mixture of text, categorical data, and numerical data, and it fits models to all of that.
Yes, okay. Can I ask you a question? Like what you've shown so far it's not like totally out of sample, right? Because like you have your training data, you have your validation data, you're going over all these models to sort of fit the validation data. But like, what if you have a completely held out sample?
This is on the held out sample. Yeah. So this is all. So what it does here actually is it will, let me just go back to where I split this data set. It is completely held out. So one sec, let me just find.
So basically you have training, validation, and the held out set. So those 90% things are for the held out set.
The 20% I held out is for the holdout, correct? That's right. And then what it does is it takes the training and further splits it into training and validation. But
okay, so it takes the 80%.
Yeah. But it does cross validation in there through bagging. So it's running multiple cuts of that 80% into smaller sets as well.
Okay, so the 20% was never seen before.
Never seen before, correct? It's totally held out. Yeah.
All right, got it.
Yeah. In fact, AutoGluon, it literally will. Let me show it to you. I'll get to that slide and I'll show it to you as well. So this was just Altman. I'll skip over this because we don't. I'm just trying to look at. Yeah, I think I'll skip over this. I want to show you a few more things. So this was the card I just ran. We actually get the data by curating SEC data sets. And for that, there's a solution for it. So you can literally create an SEC data set with a single function call. This is the workflow that I've been following, Harry. There's one subsystem called FinText, which will do an API call and get the SEC data set. Then you can join it with your stock data and make it multimodal. We call that tab text. You can run NLP scoring. You can also run summarization, by the way, on the data and get columns of summaries as well. I mentioned in the talk at the conference that sometimes ML on the summary column is better than ML on the original text column because the summary column has thrown away a lot of the noise, but it also throws away a lot of context. And so there's a cool trade-off between noise and context. If you throw away a lot of text, you lose context, but you lose noise. And for some data set that works well, some data sets it doesn't. So you get that, and then this is the AutoML part I just showed you. And then there's also explanations. We have a product called Clarify that actually gives you back explanations as to which parts of the text were more critical in coming up with the rating, for example, in this case. So I'll show you the SEC filing retriever that we built, so you can see how that works. I'll just go into Jupyter Lab here, go to Jumpstart, and you can go to this dashboard. So I click on this dashboard. I've written in a whole bunch of stuff here to explain what filings are, reference some of the more recent literature on it, Locker McDonald papers, they have a recent review paper here and so on. So people who are unfamiliar with this, like PhD students starting out, can kind of get some information about it as well. I'm going to jump directly to the notebook I've run because I have it here. So this is a dashboarding notebook. It's also one of the cards. All you do is you go in here and you run this code block. What it does is it will pull in the data that you need, the resources that you need. The important thing is we have a SDK. So we had to build all these APIs into a software development kit called SMJS Industry. SMJS Industry stands for SageMaker Jumpstart Industry Toolkit. It's the financial industry. And so this will actually install that SDK for you automatically. The SDK is open, by the way, so it's fully available. And I'll show you the documentation for that too. And then you can read, you don't have to do anything. You just run all these blocks of code, which are reading in all the libraries that we need, including the APIs. And then you arrive at the dataset creation API. So you don't change anything. You just keep running the notebook. When you come here, you can put in the list of tickers you want. You can either put in the SEC CIK or the ticker symbol. Either one is fine. You can choose the forms you want. So I've just chosen 3 forms here, the most popular ones. You can give in the date range. So this is 8 quarters, 2019 through 2020 December. And you give the name of the data set where you want it stored. You kick this off, it spins up a container to run all this, because there's a lot of code in this as well, to go to the SEC Edgar website, pull your filings and clean them up and everything. So once you've done with that, you can see all the runtime code in the container is here. The entire thing takes about 6 minutes to do this. Of that, almost 6 minutes of that is spinning up the container resources. All these containers take time to boot up. The actual code doesn't take a long time to run. So there's 7 companies here and these forms. So they're going to get about 7 to 4, 28, 7 to 8 quarters, 56 filings of 10K, 10Q, and then a bunch of 8Ks. So when you run that, it saves the data set and you get a completely clean data set with the filings. You can see here, I just printed out that 27904 is Delta Airlines. It had 48 filings in those 2 years through the pandemic. Google had 23 8Ks and so on. So 8K is a file every time there's a material change in business conditions. And so there can be any number of 8Ks in a year. Now you want to parse the 10K into its separate sections. So there's an API here. You don't change anything, just run it. And you can see it produces the entire 10Ks with all the different bits and pieces. So if you're interested only in the risk factor section, it's clean parse text available out here. All you have to do is log into this, run the API, and the data set would be ready. If you just look at line 138 here, which is Facebook's 10K, and you want to look at the risk factor section, you can see the text has been completely parsed and clean. So you have completely clean text ready for use. It's something, I used to spend hours coding all this stuff and keeping it ready and pulling SEC filings using the Edgar API, which is not the most user-friendly thing. So I figured just build this so that people can grab the text, and do it. Separate parser for the 10Qs. The 10Qs have a slightly different structure, but again, you get all the different sections of the 10Q available, and then the 8Ks are here as well. Then you can do NLP scoring, like I've already shown you before. I call on the same data set, I call the NLP scoring, runs in a container, and then gives me back the scores for the text. Okay. And then you can actually take that and construct a dashboard. So if you take a whole bunch of companies and put it in here, the rest of the code in this notebook actually adds summaries and creates an interactive dashboard as well. So I can show you the dashboard because I just did it for a small number of companies. It'll actually generate this, and then you can sort the companies by these things and so on. Okay, so it's just a way to filter companies. And so what we really built in this notebook is a stock screener, but the stock screener is using text for screening rather than using the regular financials for screening. Okay, so that was just a really quick run through. I'm just trying to watch time here to curate a data set of SEC filings. So the first step would be, if you want SEC filings, you just get into Jumpstart, you go to that particular solution and you create your notebooks. You run the notebook and you get a data set. Okay, so
just how can I ask a question? Like, how accessible is this code if you want to run it outside of AWS? Like,
you won't be able to do that.
Yeah, you won't. It uses internal plumbing and stuff. So
right. There's a bunch of internal plumbing, but the advantage of this is you actually, it's like you either pay cost and time, you pay cost and compute. And over here, your cost and time is 0 because it's prepackaged. The cost of compute, for example, to produce that thing for 6 minutes on that machine would have cost about 3 cents or 4 cents. So it's a lot cheaper than even buying a data set of SEC filings. Okay, so if you run that machine, and I ran it for like 5,000 filings, it ran for about 45 minutes. It costs, less than 10 cents,
and what's the licensing with the data? Like, if you run, like, is it like when you run that and it generates the data, like, is this considered open,
your data.
like
It's
public
yours.
data. Okay, so
No, it's your
Amazon
data.
doesn't own it in any way.
No, Amazon doesn't own it. It's your data. That's why I did SEC filings, because SEC allows anybody to use the data. In fact, they are delighted that we're building things that other people can use. The more the data gets used that the SEC has, the happier they get. So it's definitely a good thing, I guess. So yeah, so yes, absolutely. SEC data, Edgar data. The only restriction SEC puts is don't crash the site by bombing it, with too many requests. And so they actually have a rate limit, which anybody who uses it has to observe, whether it's you as an academic or a tech company. The rate limit is not more than 10 requests per second. So that's the only rate limit there is. Yeah, so that was just what I wanted to show you here. Then let me go back in this. Show you a couple more things very quickly. I want to show you something using transformers, because that's important. I'll skip this. I talked about it in the talk, but we built something that generates financial lexicons automatically using embeddings, whether they're transformer-based embeddings or word-to-vec embeddings, it doesn't matter. But it literally, you pass 2 seed words like fraud and negligence, and it'll automatically generate a word list for you. So you can extend it to ESG, you can extend it to climate change work, whatever you want to do as well. Except that this is not yet available publicly, but if you want me to generate the list for you, I can do that. I'm working to get this out, but yeah, this is something that, but you can see there's no human curation of this word list. It's completely automated. And what we did was we created all that NLP scoring I've been showing you is based on word lists that are computer generated and has no human interaction whatsoever. One way to assess it is to actually take different data sets and run machine learning on those columns that are created, these credit, like fraud score, readability score, sentiment score, and so on, and see how well it does versus Lockyer McDonald. And it compares, Lockyer McDonald word lists are better because they've been human curated and sort of worked out over time, but we get pretty much similar performance. And if you use all our word lists, you get slightly better performance than Lockyer McDonald. And this paper got published early this year. So you can take a look at the paper. It's very transparent. You'll be able to write the code yourself and should be able to kind of build something like this straight out. Okay, so transformers. So I guess a lot of folks here will be familiar with transformers like BERT, and also with further training transformers to have financial knowledge. So transformer is just a big neural network in a black box. You pass your text to it or your text tokens to it, and it'll give you back a vector representation of the text, whether it's a vector representation of a single token like a word or a sentence or entire document is up to you. But you want some sort of numerical representation of the text so that you can then pass it into something like a regression or a machine learning framework. So BERT, we know, has the large version has 340 million parameters, the base version 110, and the distilled down version has 66 million parameters. So these are large networks. And how are they trained? They're basically trained by passing all the text in Wikipedia and book corpus, for example, through it. 2 types of training. One is you take a sentence and you sort of mask a couple of words, and you train the network to predict the missing words. So it starts learning context by predicting the missing words by looking at the words around that in the sentence. And so it gets really good at that. And these attention models that were sort of published in 2017, 2018 have shown how to actually capture large context quite effectively. And then the second type of training is you pass 2 sentences. Sometimes they're consecutive sentences from Wikipedia, sometimes they're not. And the machine guesses whether or not they're consecutive. So it learns context from adjoining sentences as well. And this was what BERT was, and BERT has been remarkably successful. So what people did was you can get a representation from BERT and then pass it into a downstream neural network to do classification tasks. And that's called transfer learning. Okay, we transfer all the learning from the language in Wikipedia and book corpus for downstream learning of other things, like classifying documents into sentiment and so on and so forth. Now, what you could do is you could train these models from scratch using all the data that BERT and other things like Roberta, which Facebook created to improve on BERT. You can pass all that text, plus you can pass financial text. So we took 10 years of SEC filings for the S&P 500 companies, all the 10K, 10Qs, and ran that text through the model as well. So that was trained using a fairly large platform, distributed computing platform. We ran 250,000 rounds of training using Roberta style training. So Roberta was Facebook's improvement on BERT. We created two models, a small, which had an embedding size of 768, and a large with an embedding size of 1024 numbers in a vector. We ran on a hoverboard platform, distributed training platform on 8 machines. Each machine had 8 GPUs. This ran for about 2 to 3 weeks. It's expensive. And so this is the kind of stuff you can't do at the university. You have to do it on big platforms. And so we trained, what we also did was we didn't train on the book corpus. We dropped the book corpus. We trained on all of Wikipedia corpus. And we trained on that 10 years of SEC filings. The reason we dropped the book corpus is we didn't want the regular general text from Wikipedia and book corpus to swamp the financial text. We wanted to have enough of a proportion of financial text in the pre-training that we did. And we fitted the whole thing. So if you don't have BERT, you get 86% accuracy on a very well-known financial news data set. So we wanted to test it not on SEC filing classification, but on financial news classification, even though it was only trained on SEC text. So without transformers, you get 86%. That's the best you can do. With standard BERT, you get in the range of 92%. So the error is about 8%. And then with the pre-trained models that we have, we can halve that error to about 96%. So this Roberta SEC model is a transformer model. It has about 150 million parameters in it. And I'm going to show you how to use it so you don't have to worry about all the pre-training. But if you just want to use it for machine learning with a few lines of code, I'll show you how to use it.
So can you just mention what is the classification task you're doing, like for the SEC?
We basically did missing words in the sentence, and we did not do next sentence prediction because Roberta actually showed next sentence prediction actually was not that effective. So when Facebook trained Roberta, they dropped next sentence prediction. And that's why we call these models Roberta SEC models and not BERT SEC, because we are using Roberta style training for it.
So we should think of this as like you build something that gives you like the probability of a word occurrence, given context. Like
given context in financial context as well. And the other way to think of it is, like I said in the talk, that you send a kid to school and they learn language quite well and they graduate from high school and can read English, and interpret and get context. And then they go to an undergrad program in finance and learn a whole bunch of finance vocabulary and context as well. And that's pretty much what this pre-trained model is. It's like an undergrad in finance. So we have this model. Let me go back to my code. So I go back to SageMaker Jumpstart. And what I can do is I can take the base model here and click on it. And all you have to do is deploy it. So what this will do is it'll take that entire pre-trained language model and deploy it to an endpoint. I've already done that, but it spins up a new machine for that endpoint. So the endpoint is here. You open that, it's in service. And then I open the notebook, and I have a demo notebook for this. So these are just libraries, standard libraries that you recognize, except for Boto 3. Boto 3 is Amazon's Python SDK. So that's needed. And here I'm going to get embeddings for sentences. So let me just get 2 sentences. It doesn't matter. This thing is being built. The endpoint was built so that you can throw anything at it, a word, a sentence, or an entire document. It'll generate an embedding for you. So I just created 2 sentences. You can see they are silly sentences. The code is very open here. This just tells you how to query this endpoint. So when you pass those sentences to the endpoint, it immediately computes. It passes those sentences through the neural network, which is 150 million parameters, and gives you back an embedding of size 768. That's the standard BERT size. And these are the first 5 numbers in the embedding vector, just so you can see what the scale of those numbers is. Then I want to use this embedding tool to actually get embeddings and train a model. So I wrote another function here that will actually call a column of text that you might have in a data frame and give you back an embedding for each row of that column, of that data set. So you don't have to do the hard work of building all this. You just throw the text at the endpoint, it gives you back the embedding. Two example data sets. One is a disaster tweets data set, which is a very popular data set, open source data set. People have been mining tweets And what they do is they try to get tweets that are predicting some disaster happening in the world so they can trade on it. And that's the fastest way to get that early warning information, except that you get a lot of false positives if you don't have a good model. And you don't want to keep getting triggered. So people have trained data sets on disaster. The cryptocurrency pairs is another data set. My colleague Gustavo Schwenkler, he has this paper in management science on cryptocurrency news. So I'm going to show you that data set. So this is the tweets data set. I'm just going to ignore that one for now. And I'm going to jump to the second data set and read it in. I'm just going to start it here. So here's the data set. He has articles from cryptocurrency news. And he was actually looking at how this news affects cryptocurrency trades. And he got sentences that had two tickers in them. And sometimes the sentence was about a competitive statement about the two tickers, like, Ripple is going to do better than Ether or something like that. And sometimes it was non-competitive. So the label here, 1 and 0, 1 is if the sentence is competitive about two tickers in the sentence, 0 is if it's non-competitive. And he had something like 26,000 of these articles. So 26,000 observations data set, but he didn't have the labels. So he was hand labeling them, and it's completely impossible, no matter how many PhD students you rope in to actually, label these sentences. It's awful. So he just gave me 200 of these sentences. I split it 2/3 for training, 1/3 holdout, and I ran it on this transformer model, and I got 90% accuracy, just with a very small, what you call few shot learning. So then he gave me another 259, and I hold out. I basically predicted those. He hand checked them. Again, it was 90%. So he figured then he would just relabel the rest of the data set, with this. So I'm just showing you the 459 that he gave me. Very small data set. I train test split. So 367 train, 92 for this. This code calls that function at the top of the notebook that calls this endpoint and gives me back one embedding for each of these articles. So I get back 367 embeddings of size 768. And then I get back a bunch of embeddings for the test data set, which I hold out completely separate. Now I've got these embeddings. I'm just going to throw them into TensorFlow. You could use PyTorch, anything you want. This is a really trivial neural network just for example purposes. It's got 2 layers of 128 neurons each, and then an output layer of 2 neurons because it's just a binary classification task. And anybody who's used Keras knows what this code is. I'm only running 10 rounds of training just to, keep it simple. So if I just run it, it's fitting only 115,000 parameters because the 150 million parameter thing was pre-trained. I'm not changing the weights on that. I get in-sample accuracy of 88% and an out-of-sample of about 85%, just with 10 rounds of training. And then if you train it optimally, you'll get to about 90% of this.
Sorry, can I ask a question? So yeah. You're using the Roberta model to create an embedding for the sentences, and then you're running the embedding into this other neural network to do the classification.
This is called fine-tuning. So we're just fine-tuning a classifier using that. So it's the classic transfer learning, right? I've taken the learning already on language, used it to generate an embedding. And all I needed was this block of code to call the endpoint to get the embeddings. And you can call my Roberta SEC model. And then you can do whatever you want to the embeddings. You can do clustering, you can, whatever use case you have after that is open to you. But it's giving you embeddings that are not BERT embeddings. They're actually Roberta embeddings, which have been trained on financial text.
But somehow your embedding is recognizing, or something in the embedding is giving you information that is making a comparison between two cryptocurrencies versus not. And
well, it's just plotting the whole article.
Right, it's just the whole thing, but there's enough information.
There's enough, that's right. Yeah. And that's why transfer learning is so beautiful. You can literally do these things downstream, because I paid the cost in the 3 weeks of training. That costs 30-40 grand of compute, right, to just train. And then once that trained model is there, I'm just giving you the endpoint, and you can construct a data set of embeddings from that, which can be used for any downstream task, whether it's clustering or classification or whatever you want to do with it. Now the question is, obviously, is this better than standard BERT embeddings? And that's what the paper showed. Now obviously it may not work better on some data sets. So what we did was we actually went out and did something different, which is we trained 4 of these models. We trained a large one that gives size 1024 embeddings. The base version gives 768 size embeddings, so you can play with the embedding size. And then we also trained 2 other models, like corresponding to these 2, only on the SEC text. Just because some use cases, a model that never went to high school but only went to undergrad in finance is kind of sometimes better, because it's only been pre-trained on SEC text and no other text. Usually that doesn't perform well because it hasn't understood language well enough as something that's trained on the Wikipedia and book corpuses, you know. But that's sort of a nice sort of analogy that you know, or comparison that you might want to make. So let me quickly wrap up here, and then I can hang around if there people want questions. So this is just the screenshots of what I just showed you. We did some other examples, like can you predict which industry it is just by reading the SEC filing MD&A? Can you know, and you get pretty accurate. It's pretty good at doing that. We did the Paycheck Protection Program. We were able to predict with about 90%, 92%, I think it was, accuracy, whether a company that took money in the Paycheck Protection Program would actually repay the loan or not repay the loan, just based on the SEC filings, 10K, 10Qs, and 8Ks. This was based on a paper by Prabhala and Manjupuri and Tetiana Balyuk. They have this paper on the Paycheck Protection Program. So all we did was ask them for the tickers that they used. We used the SEC downloader to download all the SEC filings for those tickers. And then we had a flag as to whether the company paid the money back or not. And you know, we just said, is the text in the filings able to discriminate between the companies that repay the money and the companies that don't repay the money? And turns out you can do that. So these are all interesting, kind of cool use. I never even wrote a paper. It's just like the notebook here. You can always take the notebook and replicate it. So it's there. The dashboarding stuff comes with this kind of radar plot. These are really useful, by the way, for comparing documents from one quarter to the next. You can see how much they overlay on the different attributes. It's just a graphical representation, nothing special here, but it's something fun you can do. Okay, so after I do that workshop, if you all are interested in that workshop, then I'll do the workshop. And then one of the things we can do is give out free credits. So Amazon sort of gives out per researcher about $300 of free credits. And depending on which machine you use, you get a whole bunch of hours of compute. So you know, we can postpone that discussion for later, but it's something to just get people started. There's a lot of resources here. For example, all the API documentation is provided. So, you know, there's plenty of documentation, like why SEC filings, all this, including the API calls. So the data loader, the API, you know, so standard document, whoever reads Python documentation is probably familiar with the structure of this documentation. The NLP scoring module is here with the API calls, the tab text. So how do you join tabular and text that comes at different frequencies? I didn't show you that. There's an API for that. You know, and this whole thing is packaged into a separate SDK that does all this. So all the documentation is available as well. So, you know, one can kind of quickly look at that. It's been published on PyPy. So the entire SDK for all these API calls is now available open. So you can take a look at that as well. It's here. I don't have time to talk about too many other things. The current state of the art is building transformers for mixed modalities. What I've shown you right now is not there yet. I'm building transformers for text, transformers for tabular, combining them with either late fusion or early fusion. But you want to ingest everything at one shot, multiple modalities, and produce one representation of that. And the biggest model right now is WuDao 2, which is about 10 times the size of GPT-3. You know, which was this monster NLG model that OpenAI produced a while back. So we're getting there, and hopefully I'll have models that look like this eventually. I don't have time to show you SageMaker Canvas, so I won't, but this is completely no code. This is like AutoML. You upload your data set and it'll run multimodal and do everything for you without you having to use notebooks. This is not very interesting for people to do research, because people who do research want to change the notebook and do different things with it. And this is just going to, you know, hide everything for you under the hood. But what I do want to show you is Studio Lab. And Studio Lab is over here. So if you grab this URL, I'll just put it in the chat for everyone. It's free SageMaker in the cloud. Okay, so you should grab that. And you can sign up for an account. You just request an account. It takes about 1 day to 5 days to get your account approved. And then literally you can sign in. So if I sign in here, this is useful. It was built for academics. You can choose whether you want a CPU machine or a GPU machine. So let's say I choose a CPU machine, I can start it up. Internal to Amazon, we've now open sourced it to all the universities. We have a book called Dive into Deep Learning, and all the notebooks related to that are available. Amazon has an internal university where we train. So I've taken courses there, and now a lot of this has been opened to academics as well. Hugging Face is sort of biggest open source NLP community. So Amazon tied up with Hugging Face, and now all their models are available through SageMaker. So you can actually run Hugging Face inside SageMaker with far less sort of coding on your own. There's hackathons here, and there's also a GitHub repo here. So you can look at different examples here. So for example, this is my contribution in here, how to install R inside this and run R concurrently with Python in the same notebook. So for example, let me just go up here. My machine has started. I can open up my machine here. And then you're basically into Jupyter. Okay, so this is Jupyter running on AWS Cloud. You can see that if I just do this, you can actually install R kernels as well and run both R and Python. And then I have some notebooks that actually run R and Python together at the same time. So here was an example. I mean, this is an R kernel. So those of you who know R probably familiar with the code. Okay, so but there's another notebook in the GitHub repo that shows you how to run Python and R in the same notebook as well. So you can actually pass data from R to Python and back. So sometimes R does things better and sometimes Python does things better. You can do that jointly. So that's available out here in the GitHub repo. So if you go to the GitHub repo and open this notebook, you can do it. You can see how to do all this stuff here. Sorry, it's the other notebook. You can actually do things interoperably. So R will run with the %R in the Python notebook, but then you can send the X variable between Python and R like this, and you can push it as well and run things in either language. So it's something I've been using a lot. Just thought I'd show that to you. So go back here. So yeah, so that's basically it. I just thought I'd show you that machine learning sort of begins with a representation of data as a vector or a tensor, whatever modality it might be. Multimodal, brings it closer to the way humans interpret multisensory data. I've shown you some common use case of integrating tabular and text data in the same model. Transformers do really well, and then multimodal transformers are now state of the art. So it's stuff that's coming. I'll stop here. Just want to mention one more thing. Sorry, I'm running a little over, but I just wanted to tell you this because I'm using it in class right now and you all might find it useful. There's AWS Academy, and I'm sure somebody at Columbia is using it. So if you want to get this for your students to use for a course, then you just fill out the application here. It's literally a 10-second, one-page application. I can give you the link. And my students are delighted with it, to be honest. It's just been one of those things they enjoy because I teach my entire courses now on SageMaker. So I teach machine learning and NLP, and I teach everything on SageMaker, and they literally get an account through this for free. They get $100 of free credits, is more than enough for a quarter course, unless they do a silly thing like leaving a very expensive machine running without paying any attention to it, which sometimes happens. But you literally log into Academy and you can, so I don't know if you'll use Canvas or on as the learning management system. If you use Canvas, this actually runs on Canvas. So students don't even see any difference. You open up, you build a course here, you add in their emails, they all get $100 of credit and they can start using it right away. And it comes with a manual for how to use it, which is a few pages, so very fast. So one of the ways to use everything I showed you is to actually open a course or teach it in a course, and then you can literally have them use it through this portal. Okay, so that's the other thing that might be worth looking at. Now, when you go to fill this out, you might find that you literally need to only fill this out. but you can't fill it out. The way Amazon has done it is somebody is the central point of contact. So I'm like the CPOC for my university. And so if you go in here and fill it out, it might tell you, hey, you're not the CPOC, somebody else is. So somewhere in Colombia, there'll be somebody who is the CPOC. So they will have to do the application for you, that's all. But they would literally go in here and put your name in and fill it out. It takes 5 seconds, 10 seconds, and then you're good to go. Okay, so I just thought I'd mention that as well. But these are the two free resources that I think are certainly worth. One is the SageMaker Studio Lab. It's basically an analogy to Colab if you're using Colab, with Google. But this is Amazon's version of it. All right, so I'll go back here and I will. I think I already shared this with you on the email, all these resources, but I can resend them to anybody who wants it. All the links to everything I talked about today are here. Okay, I'll stop. Sorry for the massive core dump, but hopefully some of it was useful to everybody.
No, this is great. Thank you, Sanjay.
Yeah.
Can I ask, so 2 questions. The Jupyter thing that ran R and Python, is that like an Amazon specific thing, or is that just like the new version of Jupyter Notebook does that?
It can run anywhere. Yeah, it can run locally on your laptop. So you can take those 2 notebooks from the Studio Lab GitHub repo and just use them in your local environment as well.
Yeah.
Okay,
yeah. Your 10K Q parser, like are those things so standardized that like what form are they XML files? Like
XML,
what do you
yeah.
actually? Okay, so they're very standard.
We chose to use the XML from Edgar, but the parser that the engineers wrote for me is really good in the sense that we built it first for 10Ks to get each section completely plain text broken out nicely. We just ran it on the 10Qs, 8Ks, and a bunch of other forms, and we didn't have to make any modifications. So that was a real unexpected bonus. We thought, okay, we're going to have to go, but we do go one by one, and so we've only done the most important filings because there doesn't seem to be demand for esoteric ones, and certainly it's not worth. It's kind of tough to keep stealing engineering resources to build these things, So as long as we do the most popular ones, I think that's gets. Most of the stuff people are doing in academic research is 10K, 10Q, 8Ks. And there's a little bit of, the proxies, def 13Ds, 13Fs, 14As, those kind of things that are also popular. But it's as people ask for it, then we call it a customer request, and then it goes into a queue and then gets done eventually, so that's how it'll. But my goal is to just keep working on stuff. I try to get signals from people in academia and industry on what's cool to build that that they don't want to build themselves, because Amazon is well set up to build these things. So it's, for me, it's been I'm actually just enjoying learning all the engineering parts of things and building stuff that other people can use. And like I said, if instead of writing one more paper, if I can help people write 10, 15 people write papers, it's a little more satisfying at this stage in my life. So, yeah. And I think this multimodal stuff is really very interesting, because I can imagine a whole bunch of cool research projects now, right, that people can do. And images we've already done. I haven't deployed something with it, but it's in AutoGluon. And so, people in finance are using geosatellite images and all kinds of other stuff. The central bank in Indonesia recently started using it to predict housing starts. So they actually have pictures of the whole country, and they're finding it to be a super useful feature, in predicting housing starts. So there's kind of, I think there's a lot of things like voice in earnings calls is another one that I think is, William Mayu at Duke has done a lot of work on it. He's in the accounting department, and he did that like 10 years ago. So it's, but I think the tools have gotten a lot better for those sorts of things. So we'll see how it goes. Yeah, there's finance is an interesting space, because I think like marketing people, I think got to machine learning a lot earlier, because of all the advertising stuff on these large tech company sites, right? Google and Facebook. And so a lot of work was done on that earlier. And I think the finance industry is regulated a lot more and slow, they move slowly and so on. So but I think we're getting to the multimodal world, and hopefully this will help.
So Melina, can I ask, do we have Sanjeev's presentation? Like, we have the PowerPoint?
I can't give you the
All right.
PowerPoint yet, Harry, because
okay.
you have only because there's I have to get it approved and all that sort of stuff.
But we have the links to everything. Okay.
Yeah. The links are better actually, because, for example, I've got blogs. So for the SEC one, I just clicked on it. I actually published the blog showing you how to use it. And this is a lot better than anything else. So it's not easy to use a cloud environment, irrespective of whose it is, because there's a bunch of learning curve there. That's why I like to do the workshop, the hands-on workshop, so that people can actually do it with me. It's not very complicated. My students pick it up in one class, and then after that, they are very, very proficient at it. So simply because all you're doing is just doing a few steps to get to the jumpstart thing. And then once you're there, you're good, so yeah, so that's, but there are lots of other stuff here. So, you can look at, I also have put all my machine learning notes up here. So if you're interested in that, I'll give it to you. I built this because I couldn't find my own code after a while. So we got, how it is, you can't find your own stuff after a while, because your drive is just full of stuff. And so that's the link to. So I literally have all my notebooks, and I have a program that creates this web page with links. And it converts all the notebooks to HTML so that they can be in here. And so if I'm looking for something like, let's say, the BAS model in marketing, I'll just do that here. Let me see if I can find it. Yeah, it'll jump to that. And then I would just want to look at, let's say, the main differential equation. It'll jump to that part of my notes. So this was my way of finding my own stuff. And every time every few months I rerun it, and it captures all the new notebooks and builds that giant index for me. So, and my students love it because my exams are open laptop, I guess, and they can quickly find stuff to help with the question. So by the way, I just got to tell you this is ML book 2 at the top in the URL. If you change this to DL book 2, just one letter change, you get all my deep learning notes as well. So I have a whole bunch of deep learning stuff here. And then if you change it to RL book 2, you'll get my reinforcement learning class stuff. And then I have one, I haven't finished and doing my finance stuff. So I have a MF book 2, but that's really a work in progress. So I'm mucking around with these. So anyway, these are just, you can feel free to use them. You're welcome to, play around with it. So it's just my way of putting my code where I can find it. Otherwise, you can't, there's no point rewriting code again from scratch, right? You might as well just find it. So, and some of the code has taken time, to put it together, like Markowitz code or even the finite differencing code tends to be fairly painful to write, so. So I have all that code somewhere. Yeah, the code is here. Yeah, so feel free to play with it, whatever. But the jumpstart stuff, let me know if you want that workshop, or if you just want to ping me and catch time to build something new, or write a paper. I'm happy to help you guys out. I don't need to be on the paper. So.
All right, thanks. That's great. Yeah, let me digest all of this, but that's a really interesting stuff.
Yeah, I'll give you the whole thing from here. Maybe I'll just cut and paste this and drop it in chat, and you can make a copy of it right now. So yeah, I hope I can just drop it into chat, and if that works, then you have the whole thing. It should work. Whoops. Oh no. Okay, let's see. Oh, paste won't work here? That's so weird. Okay, I don't know. Do one thing. Why don't you just take a screenshot of it, if you like. I'll make it big. I'll email it to you, Harry. I'll email it.
My dog is unhappy. So but thank you.
Okay, thanks. All right, I'll see you guys. Thanks, Melina. Thanks for everything. And let me know if you need the follow-up. I'm happy to do it, anytime. So
thank you, Sanjeev.
You're most welcome.
Good to see you. Bye-bye.
Bye.